In this video, we're going to look at example 4 in section 17.1. So example 4 is very similar to example 3. Here, we're being asked to find parametric equations for the portion of the parabola from x equals y squared that goes from 1, -1 to 4, 2. So this parabola is similar to the parabola we drew in example 3, but notice that the x value is y squared. So it looks like a parabola rotated on its side. So let's go ahead and draw that picture first. So here we'll have our x and y axes. So we're starting at the point, here's x, here's y. We're starting at the point 1, -1. The point here, and then we're going to the point 4 up 2. So I'll draw those in. So this is 2, this is 4, 2. And this is 1, -1. Okay, and so then our parabola, we start here at this 1, -1, and we have a parabola where the y value, or the x value, rather, is the square of y. Okay, so again, we need values or equations for x and y. So here, now, notice that the y values we can think of are functions of x. You can give me an x input, and I output the y value. The y value I output is the x value squared. Or rather, if I input a y value, I output an x. So here it's like I input -1, I output +1. Here I input 1, output 1, input 2, output 4. So we can think of this parabola as being a function of the y input. So I can write t for y, and notice that x is equal to y squared. So that would look like t squared. So my equations would be x equals, or y equals t rather, and x equals t squared. So now the question is, what are the values of t? Well, t is acting in here as my y value. So the smallest value of t I have is -1, and the largest value I have of t is 2. So this might take a little bit of just meditating, processing, convincing yourself that, yep, indeed, t here will go from -1 to 2. And again, t is kind of playing the role of y. And so we can ask ourselves, well, what's the smallest y? What's the largest y? And that will also tell us the smallest and largest t's. So then what about in vector notation? Well, we could write the vector r of t. That would look like now t squared I plus tj, where t goes from 1 to 2. And we can just double check this. So when t equals -1, what is r of -1? Well, that looks like -1 squared I plus -1j, which is I minus j, which is the point 1, -1. And just for fun, we can check when t equals 2, we get the vector r of 2, which is 2 squared I plus 2j, which is 4i plus 2j, which would bring us to the point 4, 2. And to put some orientation here, since we're starting at when y, or t rather, equals -1, we'd start at our point 1, -1, and then draw along the curve in this way. So these parametrized equations, when we start at t equals -1, we'll start here and then draw out the curve like this as t increases.